The universe is vast, beautiful, and mysterious. When you look at the night sky, you see stars shining like diamonds scattered across a velvet canvas. You see galaxies swirling like giant whirlpools of light. You see endless space stretching farther than the mind can grasp. Yet, everything you see with your eyes, with telescopes, and even with the most advanced observatories, is only a fraction of what is really out there. Scientists have discovered that most of the universe is invisible. It does not shine. It does not reflect light. It cannot be seen directly, but its presence is undeniable. This invisible substance is called dark matter. It holds galaxies together. It shapes the structure of the cosmos. It may even hold the key to the future of the universe itself. In this journey, we will explore the mystery of dark matter. We will ask what it is, how we know it exists, and why it matters for the fate of everything. This is not only a story of physics. It is a story of human curiosity, of discovery, of the relentless search for truth hidden in the stars. Dark matter is one of the greatest unsolved mysteries in science. It makes up most of the matter in the universe, yet it is invisible, silent, and hidden. To understand dark matter, let us first consider what the universe is made of. All the stars, planets, gas clouds, dust, and even human beings are made of ordinary matter. Scientists call this baryonic matter. This includes protons, neutrons, and electrons. But here's the shocking fact. Ordinary matter makes up less than 20% of all the matter in the universe. The rest, more than 80%, is dark matter. Dark matter does not emit light. It does not absorb light. It does not interact with electromagnetic radiation. That is why telescopes cannot see it. Yet scientists know it is there. Why? Because of its gravity. Dark matter pulls on stars, on galaxies, and even on light itself. When astronomers look at galaxies, they see stars spinning around the center at incredible speeds. If only ordinary matter existed, those galaxies would fly apart. The stars would scatter into space, but they do not. Something invisible is holding them together. That something is dark matter. The name may suggest emptiness, but dark matter is not empty space. It is a real substance. Scientists believe it may be made of particles that do not interact with light, but do interact through gravity. In this way, dark matter is like a ghost. You cannot see it. You cannot touch it, but you feel its presence everywhere. The story of dark matter begins not with modern telescopes, but with the careful eyes of astronomers who measured the movements of galaxies nearly 1 century ago. In the 1930s, a Swiss astronomer named Fritz Zwicky studied a cluster of galaxies known as the Coma cluster. He calculated how fast the galaxies were moving inside the cluster. To his surprise, the galaxies were moving so quickly that they should have escaped the cluster's gravity. But they did not. Zwicky proposed that there must be hidden matter providing the extra gravity to hold the cluster together. He called it missing mass. At the time, his idea was bold and controversial. Decades later, in the 1970s, astronomer Vera Rubin studied the rotation curves of spiral galaxies. She measured how fast stars were orbiting the centers of galaxies. According to Newtonian physics, stars farther from the center should orbit more slowly, just like planets farther from the sun move more slowly. But Rubin found something extraordinary. The stars on the outer edges of galaxies were moving just as fast as the stars near the center. This defied all expectations. The only explanation was that vast amounts of invisible matter surrounded the galaxies, creating a gravitational halo. These discoveries provided the strongest evidence that dark matter exists. Since then, observations have confirmed it again and again. Gravitational lensing, where massive objects bend the light of distant galaxies, shows us invisible mass warping space. The cosmic microwave background, the faint afterglow of the Big Bang, reveals patterns that match a universe filled mostly with dark matter. Together, these observations form a picture that is impossible to ignore. Dark matter is real, and it dominates the cosmos. If dark matter is real, what is it made of? This is the greatest question in modern physics. One leading idea is that dark matter is made of exotic particles. These particles would be different from the protons, neutrons, and electrons that make up ordinary matter. Scientists have proposed candidates. One of them is called WIMPs, or weakly interacting massive particles. WIMPs would be heavy, invisible, and interact only through gravity and the weak nuclear force. If they exist, billions of them could be passing through your body right now without leaving a trace. Another candidate is the axion, a tiny lightweight particle first proposed to solve a puzzle in particle physics. If axions exist, they could form an invisible field that permeates the universe. There are also theories about sterile neutrinos, particles similar to neutrinos but even more elusive. Physicists around the world are searching for these particles. Deep underground laboratories use giant detectors filled with liquid xenon to catch rare signals of dark matter colliding with atoms. Powerful particle accelerators, like the Large Hadron Collider in Geneva, attempt to create dark matter particles in high-energy collisions. So far, the search has not found definitive proof, but every experiment teaches us something new. The absence of evidence helps scientists rule out possibilities and narrow the hunt. This is the beauty of science. Even in the darkness, each step forward brings us closer to the truth. When we look at the grand design of the cosmos, we see galaxies spiraling like cosmic whirlpools, their arms glittering with billions of stars. But without dark matter, these galaxies could not exist in the form we see today. Imagine a spinning carousel. If you sit near the edge, you feel as if you will be thrown off. The faster it spins, the harder it is to hold on. Now picture a galaxy. Stars near the edge move at speeds so fast they should fly away into space. Ordinary matter alone does not provide enough gravity to keep them bound. The visible stars, gas, and dust simply do not add up. What holds them together is the unseen mass of dark matter. It forms a vast halo around every galaxy, an invisible cocoon of gravity. This halo not only holds galaxies together, it also shapes how they form. In the early universe, shortly after the Big Bang, matter was spread out like a thin mist. Tiny fluctuations in density became seeds for cosmic structures. Dark matter, with its extra gravity, amplified these seeds. It drew ordinary matter into clumps, forming the first stars and galaxies. Without dark matter, the universe might still be a diffuse fog, with no stars, no planets, and no life. Computer simulations show this process clearly. When scientists model the universe with only visible matter, galaxies do not form as we observe them. But when dark matter is added, the simulations produce structures that match the real cosmos. Dark matter is the invisible architect of the universe. It gave galaxies their shape and stability. It gave stars their homes. And it made possible the conditions for life to emerge. The influence of dark matter stretches far beyond individual galaxies. It shapes the very skeleton of the universe. On the largest scales, galaxies are not scattered randomly through space. They are arranged in a vast cosmic web. Galaxies cluster together in filaments that stretch for millions of light years. These filaments weave across the universe, separated by enormous voids of empty space. What created this cosmic web is the gravity of dark matter. After the Big Bang, dark matter clumped together first, forming invisible filaments. Ordinary matter fell into these structures, lighting them up with galaxies and stars. The result is a universe that resembles a giant three-dimensional spiderweb, with dark matter forming the threads. Scientists have mapped this structure using surveys of galaxies and gravitational lensing. These maps reveal patterns that match computer models of dark matter perfectly. The cosmic web tells us that dark matter is not just a local mystery, but the dominant force shaping the large-scale universe. It also gives us clues about the nature of dark matter itself. Different types of dark matter particles would form slightly different webs. By studying the cosmic structure, scientists can test which theories are more likely. In this way, the entire universe becomes a laboratory. Every galaxy, every cluster, every filament is evidence pointing toward the truth of dark matter. When scientists speak of the hidden universe, dark matter is only half of the story. The other half is even more mysterious, and it is called dark energy. Dark matter pulls things together with gravity. Dark energy pushes them apart. It is the unknown force driving the accelerated expansion of the universe. In the late 1990s, astronomers studying distant supernovae discovered that the universe was not slowing down as expected. Instead, its expansion was speeding up. This shocking discovery revealed the presence of something unseen, something stronger than the pull of gravity. Today, scientists estimate that ordinary matter makes up less than 5% of the universe. Dark matter accounts for about 27%, and dark energy makes up the rest, about 68%. This means that everything we see, all the galaxies, stars, and planets, is just the tip of the iceberg. The overwhelming majority of the universe is invisible and unknown. Dark matter and dark energy are different, but they are deeply connected in the story of the cosmos. Together, they determine the shape, the structure, and the ultimate fate of everything. If dark matter is the glue that holds the universe together, dark energy is the mysterious breath that pushes it apart. The balance between the two will decide whether the cosmos expands forever, slows down, or collapses in the distant future. The challenge for science is to understand both. We must find what dark matter is made of, and we must discover the nature of dark energy. Only then will we grasp the true composition of the universe. What does dark matter mean for the future of the cosmos? The answer lies in the balance between dark matter, dark energy, and ordinary matter. If gravity from dark matter were strong enough, it might eventually slow the expansion of the universe. Galaxies could stop receding and begin to collapse inward. In this scenario, everything would end in what scientists call the Big Crunch. The universe would shrink back into a dense state, perhaps to be reborn again. But the discovery of dark energy suggests a different fate. If dark energy continues to drive accelerated expansion, galaxies will drift farther and farther apart. Stars will burn out. New stars will stop forming. The night sky will grow dark as galaxies vanish beyond the horizon. This is called the heat death of the universe, a cold, empty future where energy is evenly spread and no structures remain. There are also more speculative ideas. If dark energy grows stronger over time, it could tear galaxies, stars, planets, and even atoms apart in a catastrophic event known as the Big Rip. All of these scenarios depend on what dark matter and dark energy truly are. Until we understand them, the fate of the universe remains uncertain. What is certain is that dark matter has already shaped our past. It has given rise to galaxies, stars, and life itself. And in the distant future, it will continue to influence the grand destiny of the cosmos. The mystery of dark matter has inspired some of the most ambitious experiments in science. Across the world, teams of researchers are building extraordinary machines to catch a glimpse of the invisible. In the mountains of Italy, in the deserts of the United States, and deep beneath the ice of Antarctica, detectors are waiting in silence. They are shielded from cosmic rays and background noise, hoping for the faint signal of a dark matter particle colliding with ordinary matter. The Large Hadron Collider in Geneva smashes particles together at nearly the speed of light. Scientists hope that in the wreckage of these collisions, dark matter might reveal itself. Astronomers use telescopes that see not only visible light, but also gamma rays, X-rays, and radio waves. They search for indirect signs of dark matter, such as annihilations that could produce detectable radiation. Space missions, such as those by NASA and the European Space Agency, map the universe in exquisite detail. They measure how galaxies move, how light bends, and how the cosmic microwave background shifts. Every observation brings us closer to answers. The search is not easy. Dark matter has evaded detection for decades. Some scientists even wonder if our understanding of gravity itself needs revision. Modified gravity theories suggest that maybe there is no dark matter at all, only a need to change the laws of physics. But most evidence continues to point toward dark matter as a real physical substance. The hunt goes on, driven by human curiosity and determination. Perhaps one day soon a signal will be detected. A new particle will be discovered. A breakthrough will unlock the secret, and the dark universe will no longer be hidden. Dark matter is one of the greatest mysteries in all of science. It is the invisible thread that holds galaxies together. The silent architect of the cosmic web, the unseen hand shaping the destiny of the universe. We cannot see it, but we know it is there. Its gravity has guided the story of the cosmos from the first moments after the Big Bang. Without it, galaxies would not exist, stars would not shine, and life might never have arisen. Search for dark matter is not only about solving a scientific puzzle, it is about our place in the universe. It is about understanding the hidden forces that make existence possible. The journey is far from over. In laboratories, in observatories, and in the minds of scientists, the quest continues. Every step brings us closer to uncovering the truth of what holds the universe together. As you look at the night sky, remember that the stars are only part of the story. Beyond the light lies a greater reality, a hidden universe waiting to be revealed. This is the dark mystery of dark matter, and it is a mystery that will define the future of science, discovery, and our understanding of the cosmos.